So what I'm going to do, so that you can see a little bit clearer, is I'm going to try again to trick it a little bit here to think that my screen is bigger. Okay, that'll work. Okay. So we're going to talk about the rationale of using R. And let's see, on Monday, Tuesday, and Wednesday, you saw a little bit of MATLAB code, I gather. And what else? Next week will be Python. So somebody's going to be, oh my gosh, what are these guys thinking about? Who's going to spend the time to learn R, Python, MATLAB? And some people are going to show Unix commands. You know, well, so why is it like this, really? Why is, you know, what's all this? Yeah.
Complex processing needs specialized tools.
Okay, complex processes need specialized tools, but why can't these guys, you know, you and I and Joe Schmo, why can't we get in the same room? Because, you know, I mean, programming, you know, you guys are too young to remember, but when I was in college, we had the punch cards, you know, and 2 punch cards, you know, it's machine language. You code the same sentence and I code it, it's the same punch card. I can plug it in your machine, you plug it in my machine. You know, there were standards. Now we're coding, you know, well, it is an incredible feat of human ingenuity, the fact that we have all these alternative ways of thinking about processes, okay? So you don't have to become experts in any of these, and believe me, I'm certainly not, but you have to have a little bit of exposure. You know, I've done coding, you know, machine language, yeah, I had a class, you know, it's crazy, nobody codes in machine language. But the next to machine language is programming in C and C++. You know, it's as far down to the kernel of the operating system as possible. And, you know, I've written hundreds, thousands of lines of code in C, not in the past 2 decades. Why? Well, because speed that it gives you and power to get the native system resources, we don't need it anymore. You know, high-level programming languages, you know, that's what you do. A single sentence in C may take, you know, 10 to 20 to 30 lines of code. So people like to code, and people always simplify, right? Then came object-oriented programming back in the mid-90s. You know, Java, you know, and all the other languages after Java, after the mid-1990s, everything is kind of object-oriented, you know. So we've got these objects. So what are objects? Because this term is going to come up, right? I know the computer scientists, the engineers, you guys know what objects are. For the rest of you, an object is an instance of a container that stores members. And members could be data elements, structures, descriptors, metadata, functions. So you can think about, you know, there's many examples of objects, but an object itself comes up with functionalities, just not a data structure, the way the pure language C is, right? It's not just a data storage container. It's a container that has members that are not necessarily data. They could be references, they could be functions, they could be methods, you know, a variety of things. So, you know, it is interesting. So we're going to talk about the rationale of why do we use R as opposed to MATLAB. And, you know, typically you would get to associate with a language that's your primary language. For me, you know, I started with C, then I went into Java. You know, I've got hundreds of apps in Java. I personally think Java was the most incredible language, but lately it's coming out of fashion simply because the front ends, the GUIs, the graphical user interfaces, have been suppressed by most of the app developers and the browser technologies, mostly because of hype. But Java is a beautiful language, and if you want to learn a new language, a new lower level language, Java is the way to go, I believe. But we're going to be using R. We're going to see some demonstrations. We're going to look at how to install R and how to use its graphical user interface called RStudio. We're going to show some R commands, introduce data stratification and subsetting, some simple things about, you know, generating cohorts, right? We've got a huge collection like the ADNI, like the PPMI that I mentioned earlier, and you want to separate the individuals into clusters or groups by their clinical phenotypes. So how to do these types of things we're going to talk about generically, you see. And then we're going to talk about some of the mathematical operands, functions, how you compute various statistics. Matrices, we're going to downplay a little bit matrices, because not all of us are necessarily, and you don't have to be a math whiz, I guess, to deal with some of these matrix operations. And then we're going to talk about visualization in R, as opposed to the web-based thing that I showed you earlier. And then a little bit about model fitting. So let's start off with why use R. Well, it's one of the largest open source communities. 100,000 and over developers. 20,000 R packages, you guys. Nothing out there gets close to what R has. In terms of, I'm talking about statistical computing. There is more Fortran libraries out there, and more C libraries, and certainly more Java scientific libraries. But when it comes down to statistical computing, the most innovative statistical computing things are always implemented in R and validated in R first. In fact, you know, a bold statement would be, if it's not in the R archive, it's not fully validated. Everything else, you know, you look at SAS, Stata, SPSS. These are toy languages, you know. These mostly work with, you know, spreadsheets on the order of, you know, a few hundred rows by maybe a few thousand columns or something like this. You know, important problems, but not, you know, on a, this is as far high up as it gets. But sometimes to get to the top, you gotta do a little bit of work on the bottom, if you know what I mean. So, you know, there's pros and cons, look them up. Obviously the learning curve is a bit steeper for R, okay? And for some of these other languages, you know, you put in front of an in front of a SAS terminal, you know, click here, load the data, put it in, you know, manipulate the columns, click and paste, you know, these are mostly things that are standard. There is licensing issues that come up with some of these proprietary products, and you got to be very concerned with this because your license will expire. My licenses certainly have in the past when I used to use them. So there is pros and cons. Now let me show you a little bit about when it comes down to comparing most of the things. Okay, so here's your Python. Julia is a recent language for, again, big statistical computing data. R, the interactive data language, IDL, is popular as well. MATLAB, Scalar, C, and Fortran. So I've created this table that kind of tries to provide you a little bit of intuition about what the different platforms offer you. So whether or not it's open source, and again, I'm a huge believer of open science, which includes open source and fair data sharing and all that business. But this is important for me. Again, if you coded something and you patented the algorithm, you know, I can't integrate your algorithm with anything that I'm doing because I share stuff openly, and your license is viral. It infects my stuff, so it goes out. It's not in my world. It's a different universe. So if you want to stay with proprietary stuff, then that's a different level, you know. You know, during those 3 days that you're with me, we're in the open science community, and this is very important for us. Speed is important for everybody, right? I mean, I'll show you. We've got thousands of subjects going through hundreds of steps. How do you do that? You know, time becomes an issue, believe it or not, and I'll show you some examples. Well, okay, so look at R here. So R is, these are extrapolations, okay? It depends, well, exactly what test did you run, what benchmark data did you use. You know, there's quite a bit of variability when it comes down to these scores, but higher typically means better. So the speed of R is very marginal. It's at the bottom of the pack. If you want speed, if you're a high octane guy, you know, you want to go, you know, fast, R is not where you want to go. Well, with some exceptions, because R, you know, it actually allows you to write your code in a very low-level language like C and just use R to invoke it. So all the calculations happen natively down in C, and that's how you can export it. But I'm talking about using standard R, standard libraries, a lot of interpretation. You can think about R. It's not an interpreted language, but you can think about it as an interpreted scripting language. Okay? And because it's interpreted, it's not compiled, it's not very efficient, right? But again, if you want efficiency, you can hard code your highly compute intensive kernel in C and just use R to code that object, and then it's going to run as fast as you coded the object in C. R has nothing to do with the actual execution. So what I'm saying is that take this with a grain of salt. The slowest of all is R. MATLAB, you know, so Scala is the very optimized. C is absolutely, you know, Julia and C are, you know, the top performance if you want to look at speed. Computational time is obviously inversely related, right? Speed and time, you guys. So here for the compute time, you want the fastest, and you see one task took Julia less than a second. You know, R may take 700. That's 12 minutes or so. You know, a huge order of magnitude slower, but that's what it is. But then look at the library extent, you guys. The library extent tells you how much functionality is available for you to tap on. Okay? And look at R. 100. This is the top stuff. C, you can obviously do everything in C. Fortran, you know, I mean, who codes in Fortran any longer? There's a lot of good Fortran code. Even some of the R packages might tap into existent Fortran code, but you can do a lot of things. And then look at MATLAB. You can Scala, Python. You know, there is a variety of extent, I guess, in terms of the libraries that you have available to you. Ease of entry kind of tells you how quickly you can step in that environment and do something meaningful. So, you know, there is a bit of investment that you have to do in some of these things. Costs associated. All the proprietary languages would have cost. Now, cost is not always money, or it's not always licensing. It's the burden that you incur by kind of committing to, because, you know, we're going to be going through right now and installing it. Well, that's a commitment. You got to go ahead and update your R in 2 months. Well, that's a commitment. So time and money, you know the proverb, right? Time is money, money is time, you know, whatever. So cost is not just monetary cost, but cost of ownership, if you know what I mean. So, and R is a very, very lightweight thing. Very lightweight, very elegantly structured. And interoperability, very highly interoperable. Some of the other things that are proprietary, well, you can install other things. Again, you don't need that, but you see very soon how much advantage you have by running stuff in RStudio. Okay, so let's go ahead, and if you haven't done this, just right-click here, install this, install RStudio. I think Eric just installed it this morning. Okay, that's fine. So here you're going to be done. So RStudio makes their money from essentially licensing either system-wide versions for big services, for big companies, or supporting these RShiny servers that allow you to write code. And you know, it's interesting. I wasn't planning on showing that, but if you want to know, well, I've written this R code, and I want to make it available for other people. How do I do that? Well, you provide it as an RShiny object, which gives you a URL address for your specific app. And some cool things arise. So these people at our studio, they allow you to run our services on your own hardware, so that people don't go to shiny.io, but they go to myorganization.org, and then you provide the service, not them. Anyways, so products are studio, and this is the Server Pro, which is very expensive, by the way, but we're not in that business. So let me see. Again, it's going to be the same experience. The 3 different platforms, you're going to be downloading the corresponding binaries. Installing will take, whatever, 30 seconds to 60 seconds. So why don't we just focus on the folks that do not have our studio yet? The rest of you guys, who doesn't have our studio yet? You don't? You have? Okay. You don't? Okay. You started already? Okay. Anybody else in the back? You guys have our studio? Okay. Very well. Oh my goodness. Is it a network issue or?
Yeah, it's a
Okay. Okay, so I'm going to stop this then to release a little bit of network pressure. So for the folks that have it, go ahead, you guys, and start looking at down the notes a little bit about the organization of our studio. Maybe grab some of the code. I will also start. Eric, did you install RStudio or did you just download it here?
Just download it.
So is that going to download? Okay, so Eric is going to show you now how.
Yeah.
Wait.
Okay, on the Mac it's really easy. You download the .dmg file. Once you open it, you see a link to applications folder. Go ahead and open that. And this is your RStudio. Your RStudio, the .dmg file opens up like a disk. All you need to do is click on this. Left click, hold the left button down, drag into the applications folder until you see the plus sign, release.
So the double click doesn't work?
The Mac did not already install the programs are standalone. So it's copied. I just double click on this now.
Okay. Okay. Great.
It must be the search of downloads.
Okay, but it's not projecting on that.
It's not detecting the receivers. There's maybe too many wireless connections. It probably just dropped. Couldn't detect the receiver.
Okay. So the folks in the back, the monitors are not working. Can you guys see that, or is it too far? Well, Okay, well, if you guys need to see that and you can't, we can either move some of the tables or there is a few extra seats here, I suppose. Now that, so let me see. You're still not working, right? Okay. Oh, finished. Do you have this? Do you have the RStudio now? Do I have? Okay, so everybody has RStudio now.
Yeah.
Open. Okay, so let's see. I'm going to maximize it, and under, let me see, was it view? Okay, zoom in. Okay, that's probably a little bit better. I can maybe zoom in a little bit more.
So maximize the screen by clicking on the green.
Right, I did, but I won't, right. All right, so there is, let me just see here, view. Okay, that's what I want. Okay, so you guys, let's just pay attention a little bit. Some of this is described in the notes over here. You know, about the different panels, I guess, and whatnot. So I'll just tell you on this instance. So I'm running an instance of RStudio. It's got 4 basic blocks. So on a Mac, on a PC, the options are right up here on the top bar. But you basically have, you know, file, imports, exports, you know, imports of data, saving and whatnot, editing tools, code. View is where I zoomed in a little bit, and there is quite a bit of customization. Some people, for example, like to have a black background or something. You can highly customize the experience of the RStudio, depending upon, you know, what you like. You can change the fonts, etc., etc. So play with this later. But roughly speaking, sometimes your R session may get in some kind of an infinite loop or something. You can terminate R, restart R directly from RStudio. This comes in handy once in a while. Tools. Now here, remember what I did early on. Let's see if I still have it in my buffer. Okay, I need that, and then I need some of the other things that I did to get this to replicate. So let's go ahead and grab this with the mouse, copy, paste it in here. Now, so I have the source code here. Now look, I require simply means if you have these packages, load them in my instance, because you're running an instance of the R in virtual machine, okay? And now you can run things 2 ways. The first one, oh my gosh, it's coming out of, let's see. The first way to run things is you highlight the line that you want to run, and you see what I did here is I simply clicked on this button to add up a new R script. You guys? See, I can add up tabs here with different source code. So you should give these things names and typically save them. I can save, let's save the first one because let's see, file, save as, and I like to save things in my desktop. Where is the desktop? Oh, desktop is this one, right? Okay. And I'm going to code test1.r. Remember, every script that you save in R needs to have the extension of .r so that it's properly interpreted. Later, we're going to talk about R markdown files, which are really cool, and many of you can make a great use of them. The examples that I provide in the book are R markdown code. but it's equivalent to R. So I'm going to call this test1.r, and now you see how we changed this unknown name here in the tab to R, to test1.r. And again, if I highlight this line and just click run, it tells me, it runs it. This is the console. This is where the R run script. This is my file that I'm playing with. And on the top right corner, I have environmental variables, some of the history that I've run, etc. Because sometimes you may want to push this history to console or to source if you want to redo some of these things. You see? Okay. Now it tells me that this package ggplot is not available. So no such package. So here's the critical part. The R environment that we loaded comes very lightweight, and that's why it's so quick to download. It only comes with some rudimentary functions. Most of the advanced functions, they're coded independently as R packages, and for whatever library you need to download the library and then load it into the R session to be able to use the functionality. So let's demonstrate how this happens. If you go to packages, see, these are the packages that currently came with the R installation. There is about 30 of them. Notice how some of them are toggled on and some of them are not. The ones that are not toggled on are available to you, but they're not currently loaded in your R session because they're not critical packages, and every time they're loaded into R, they occupy some resources that can be used for other things. So you don't load everything unless you need it. It's a very important lesson. Okay? So this package, ggplot2, I'm going to copy the name, and I'm going to go into Tools and Install Packages to go ahead and download the ggplot package locally. And I'm going to paste it in here. And it's going to ask you, well, where do you want to download it from? And where do you want to put it? Let's just keep the defaults for now. And I'm going to click install. Probably most of you would have to do that. You guys, is everybody here with me? So again, Tools, Install, give the name of the package you want to install, click Install. And you see what happens here in the R shell. Okay, it's working on installing the package. So this works a little bit different than on a PC. So what it's doing right now is it's trying to retrieve I think it's downloading right now the ggplot package from the internet and putting the binaries locally, but it doesn't make them automatically available in my current shell until I load them into the my R environment. So we got to give it a minute here. I have to do the very same thing for reshape. Yeah.
What's the difference between require and library?
It's the same thing. Require and library is the same thing. It just loads them in. And in fact, if you right up here, see, I tried to look for ggplot. It's not available. So if you toggle boot, for example, it uses library by default. I tend to require, it's the same command. I think one offers more options or something like that. It just brings it into the environment. Again, it reduces the amount of available resources. So if you don't use something, always detach it so that it releases some of the requirements. So all right, we're going to give it a minute. You're probably facing the same thing. It's
Try to switch to a different wireless network.
Yeah, so that may be a persistent problem as you go forward because, I mean, there is 30 of us accessing, you know, a 10 megabyte, which is a very, very small thing, times 30. Now you're talking serious data going through wireless.
So I recommend you swap to the Cape guest wireless network to do the install.
But if all of us swap to that network, we're going to have the same problem. So, I don't know, evenly distribute, I guess. So, notice before we press on, sometimes when you install packages, they have dependencies. In other words, the functionality in one package requires something else. So this package, ggplot, requires oh no, we don't want to install from source. I just want the binary, so probably no in this case. You can install from the raw source file, or you can just download the binaries which are already pre-built for your specific operating system. It's always easier to just download the pre-built libraries. But I was going to point out that you see all these things? It's downloading different dependencies that it needs. So GG table, for example, so variety of, so it's going to, again, every package when it's released through the CRAN library declares specific dependencies. They're all installed here. So now you guys, if I do the same search here, so again, the panels, here is the source code that you save on local hard disk. Here is your environmental variables and history of things that you ran, you guys. You can always click on this and put it into the source or put it into the console. So the history is important. The environment shows you what variables. I don't have anything in my environment yet. I haven't defined anything. But soon I'm going to define a data object that stores these 3 columns, remember, for the publications. And I'm going to have one object here. And then, so, source code. This is the execution, which is the pure R that you can run. Here is environment and history. And here is a whole bunch of things, including plots that we're going to be generating, some things about files, the packages that you currently have access to. Remember, a second ago I searched for ggplot and it says not inappropriate found. If I search for ggplot now, it should tell me that ggplot is available. It's not loaded in R, so I can either type in require and push it, run it, or I can just toggle this thing off, which does the same thing. It makes this package available, and it's all of its members and functionality available for use. Is everybody here with me? No. So 2 ways to load the package into the R instance for use. So I typically use that version. You can also use, you can also just run the require. It does the same thing. So let's do the same thing with the reshape now. Let's try to see if reshape is available here. Okay, reshape was available. Let's see where it is. Reshape. Okay, it's already loaded in.